Hey everybody! So you just watched a short video defining what a scatter plot is and also talking about the relationship between the two sets of data and whether they have a positive correlation, a negative correlation, or no correlation. So in this example that we're going to do together, I'm actually going to give you a set of data. We're going to construct a scatter plot and sketch what's called a line of best fit, which is just a straight line that pretty much models our set of data. And then we're going to write the equation for that line and use it to make future predictions about our data. So I posted a blank copy of this on Schoology. If you're able to print it off, great, and you can kind of copy along and do what we do. If you can't print it off, that's not a problem, but I would definitely make sure you're copying the notes down and especially the work that we do onto a separate notebook paper, because you will need that work to help you do your two practice problems on your own. So the table below shows the number of calories burned by a student walking around the track. And we're talking about the laps completed and the calories this student burns. So in part A, if I ask you to construct a scatter plot, the first thing we actually want to do is label your axes, just like we've done in the past. So I'm going to let X be laps and Y be calories. And then I'm going to label laps on the X-axis and calories on the y-axis, okay? And then we're going to plot these as ordered pairs. So 135, you're going to plot as the ordered pair 135, okay? And do your best to pretty much get the point approximately where it should be. It might not be exact, but do your best. 275, 385, 4 130, 5 150, 6 175, and 7 220, which is all the way up here. Okay. So if I look at my points here, based on the video you just watched, can you tell that this has a positive correlation? All of the points are going up, almost like they have a positive slope. And remember, a positive correlation means that as X increases, so does Y. So let's see, that should make sense here. As the number of laps this student does increases, the number of calories they burn also increase. So that makes sense. So that's why this has a positive correlation. So here's our scatter plot, and now what we're going to do is sketch in what's called a line of best fit. So if we were at school, I would give you a clear ruler to do this, because the line of best fit should be a line that pretty much goes through the middle of your data points. So if I had given you a clear ruler, what we'd be looking at is to make sure like half of the points are above and half of the points are below this line. But since we're not at school, I don't have a ruler to give you. I'm at home. I don't even have a clear ruler or anything like that. So I'm just going to use the side of a notebook page, and I would encourage you to just use like a straight edge. So maybe the side of your calculator or the side of a notebook, all right? And when you're sketching in this line, we want it to kind of model our points. We want it to go through our points kind of like I said, so maybe about half the points are above and half the points are below. It doesn't have to go through every single point. It might not go through any points, but I don't want it to come down. I don't want to make a negative slope line because this is a positive correlation. I don't want to draw a line that goes straight across because that doesn't really model the path of these points. So you're going to take a straight edge, and to the best of your ability, you're just going to kind of sketch a line that maybe goes through some of the points, or at least so that half the points are above and half the points are below. So I'm going to kind of look at something like that, okay? All right, so that line pretty closely models all the points. The points are pretty close together around that line. Everybody's line might look a little bit different, but just make sure you're getting as close to those points as possible. In part B, what I want to do is actually write the equation of that line. So if you recall back from our unit on linear equations, in order to write the equation of a line, I need 2 points. So what you're going to do is you're going to scan your line and look for 2 points that the line passes through. They do not need to be points that were in this table. All right? They could be points that pass through on the graph, but they don't necessarily have to be points on that table. So what you want to do is you want to scan your line and kind of look to see where your graph crosses through. So if I'm kind of scanning my line, all right, that looks like a point, 4 and 130. And if I keep scanning the line, maybe this looks like a point 2, all right, 150. Okay, so when I scanned my line, it looked like it went through the point 150 and the point 4, 130. Now you can see 4, 130 was part of the data set, but the point 150 was not. That's fine. You might even have 2 points that aren't in the data set. That's okay too. When you guys do your homework, you might all have different points that you use. But again, what I'm looking for is that the end result is kind of close. Everyone should kind of have numbers for the slope and the y-intercept that are around the same. So if I want to write the equation of a line through 2 points, the one thing that I need to do first is find the slope. Okay, and if you remember the slope formula, it's y2 minus y1 over x2 minus x1. All right, so calculate that slope. 130 minus 50 is 80. 4 minus 1 is 3. And we can actually divide here and do 80 divided by 3. And I'm going to get about 26.667. So I'm just going to make that 26.7. Now you might get 27. Maybe you get 28. Maybe you get 25. What I'm looking for is a number that's all kind of around, we're kind of looking at numbers that are all around each other. You shouldn't get something like 100. You shouldn't get something like negative 26 because this is a positive slope. After you find the slope of a line, remember our equation to find the slope-intercept form of a line is to use y minus y1 equals m times x minus x1, where y1 and x1 are an ordered pair and m is the slope. So I do know my slope, and then I can pick one of these 2 points. So maybe I just pick that first point. Y minus the y-coordinate is 50 equals my slope, which is 26.7, times x minus the x-coordinate, which is 1. So what I'm going to do is put this into y equals form. I'm going to distribute 26.7. So I have y minus 50 equals 26.7x minus 26.7. And then I'm going to add 50 to each side. And my final equation is y equals 26.7. And if I do negative 26.7 plus 50, I'm going to get 23.3. Again, your equation might not have decimals. Mine ended up with all decimals. Everybody's is going to be a little bit different, but what I'm looking for is a positive slope that's kind of around there and a positive y-intercept that's maybe around 23, 25, somewhere in there. And if you look at my line, can you see the y-intercept, 23.3, kind of matches right where my y-intercept is on the graph that I sketched. That shouldn't be like 40 or 50. Because look, my line is nowhere near 40 or 50 or any other numbers. So this equation models my data set, right? So one thing I want to kind of interpret is, what does the slope and y-intercept mean? So our slope is 26.7. Do you remember another word for slope is rate, or rate of change? So it's talking about how our data sets are changing. Okay, so if you kind of think about the slope of this line, it's going up 26.7 and over 1. Up 26.7 and over 1. Or if I attach the units, we're going up 26.7 calories and over 1 lap, which means this student is burning about 26.7 calories per lap. And I'm writing about because we all might get a little bit of a different answer here. Okay, but you want to define it based on the slope and y-intercept that you get from your part of the equation. Now the y-intercept, if you remember when we did word problems, the y-intercept was like the starting point. So what are we starting at here? Well, my y-intercept is 23.3. And what I'm talking about is this person walking around the track. Well, I'm starting at 23.3. On the y-axis, that means calories. So what that means is that when this student started walking, they had already burned about 23.3 calories. So when this student started walking, they had already burned about 23.3 calories. So again, use the numbers, define the numbers that you get in your equation. Okay, don't forget, these are all going to be a little bit different for everybody. So what I can finally do is, use this equation and make predictions about, well, what happens on the 8th lap or the 9th lap or the 10th lap? Or what if this person walked for 20 laps? How many calories would they burn? So part D says, use the equation to make a conjecture or a prediction about the number of calories that they could burn in lap 10. So here's my equation. Y equals 26.7x plus 23.3. Okay, I'm talking about what happens in lap 10. Well, laps is x. So we've done problems like this before where I give you a value and you think about, well, is this the x value or the y value? And we plug that into our equation. Okay, so if you think about it, x is 10 because laps refers to the x value. So I'm going to plug 10 in for x. And I'm just going to simplify. So 26.7 times 10 plus 23.3. Okay, 26.7 times 10 is 267 plus 23.3. So 267 plus 23.3 gives me about 290.3. Okay, and I don't want to leave my answer like this. I want to attach a unit to it, right? So when we're talking about 10 laps, what happened at 10 laps? Well, after 10 laps, this student burned approximately 290.3 calories. Okay, so that's what today's lesson is on, all right? And what you're going to kind of be working on this week is looking at a scatter plot, making a scatter plot, sketching in a line of best fit to the best of your ability, all right? Writing the equation of the line using the formulas we remember from the slope and the point slope formula to put it into y equals form. Telling me what does that slope and y-intercept mean. Make sure you don't just give me numbers here. I want you to give me sentences. Tell me what these values mean in context of your problem. And finally, you're going to use your equation to make predictions about the future data set.